Hello, friends. Welcome to Clarify and Decode, where our aim is to demystify software engineering. This is another part in our series of software performance improvement. So, whenever we are stuck in any performance issues, we need to think what is causing the issue. And we may have heard of various profiling options. Okay, these can also be done during the development phase itself rather than waiting for the application to degrade, crash. These practices can also be inculcated during the development or the testing phases. So let's get started. I will try to go part by part. What are their purposes? How to read them? What are the best tools? The advantages? Fine. So, as I always say, software engineering is just all the concepts exaggerated from what we see in your personal desktop. Okay, we just have to think about CPU, memory, space, disk, networking. These are the backbones. So, first, whenever there is a performance issue, we say, oh, the CPU is spiking. Has it saturated? Right? If the CPU is not healthy, that means there are performance issues, and we have to think why the CPU is spiking. So the first point would be CPU profiling. Okay, so here what do we measure? Whenever the code is running, right, CPU is getting utilized. It is spending some time on different functionalities, parts of the code's method, right? So these generally you will see when you have a lot of CPU bound operations. Okay, CPU bound operations. If you have some computation like this, then the CPU should be spiking or can be spiking, and we have to be cautious of these. Okay, so if the CPU is like around 80, 90, this is the 50% mark, these would say like okay, healthy, these part we would say acceptable. CPU is spiking, first think of algorithms. Is any particular loop, some inefficient algorithm is causing the spike? Okay, and if the CPU somehow is very low, that also can indicate an issue that there may be some bottlenecks in the code. Input output bottlenecks. Basically, the CPU is not able to do anything because it is not getting the work to itself. It's just sitting idle. It has capacity, it's healthy, but still, because the threads are like stuck, there are bottlenecks, this is going low. So if it is high, think of algorithms. If it is low, if the CPU is low, think of bottlenecks in the threads. Okay, what will CPU profiling do? Okay, there are many tools, but the basic thing is it will give you like which part of the code or which functions we should go to at least the function level, not if not possible to code level. There are many advanced tools for this which can give you hotspots at the code level, but at least try to get to the function level, which function is causing the CPU spike. You have to optimize that. Okay, I would say another thing in terms of garbage collection. So what is garbage collection? Let me just give you a brief. You have employee class in your project. It may have a lot of other objects, other classes, child classes. So whenever you keep running, whenever the traffic is high, a lot of objects are created. Okay, so suppose this is the heap. It's getting created, and this is your full memory. I'm not getting into parts of different generations of the heap. It's different in Java, .NET. Java we have Eden spaces, .NET we have Gen 0, Gen 1. But that's a different topic I will discuss. But what's happening here is, if we have a lot of objects, then garbage collection would run. Means it's running, but the frequency would be high. And whenever garbage collection is running, it is taking out the garbage, right? So who is powering this? The CPU is involved, right? Because it's a thing going on. So whenever you're doing garbage collection, the CPU is spiking. So high garbage collection, how we can think of, if the CPU has spiked, we also try to relate, is there a high GC or not? Okay, fine. Let me think if I can relate here what will happen when we can think of slow garbage collection or less frequent garbage collection. When do we think we can have less frequent garbage collection? I think it's going a slight out of the topic for memory CPU profiling stuff. I will discuss it in a separate session. Full details on garbage collection in very easy terms. So watch out for other videos. Fine. I told I would also let you know about tools, right? So CPU, we have inbuilt tools in the IDE, right? Like if you are using .NET, you will have in the Visual Studio itself, Visual Studio diagnostic tools will have it, right? Third-party tools like PerfView, but these are like dependent on the company, or if you are in doing something of your own, what is your best fit. All provide the same, I would say, functionality. It's just the flavors, some plus minus. Okay, Java, JProfiler. Okay, fine. CPU profiling, check why the CPU is spiking or going down. The second would be very important, memory profiling. Memory profiling. Yep. So here there are two things. We are doing allocation. I was just mentioning, right? Whenever we have objects, heap objects, there are allocations. Okay, the memory is getting consumed. And that is fine because allocation is required for our functionality. But if the garbage collection is not working efficiently, we are not clearing up the memory, right? So I said it's growing, but the garbage collection, collector will bring it down. But if the garbage collector is not able to bring it down because of any reasons, that is a separate topic, we would say there is a leak of memory. Okay, it's not like the memory of your system is lost. Okay, because sometimes you will say, oh, leak, what does leak mean? It's basically you have like x amount of memory, but a portion of that x amount is not reusable. It's just stuck at some place. You cannot use that because objects are just residing and there is no garbage collection happening. Okay, so we call it a leak is memory is stuck which cannot be utilized. I think they should have kept this better terminology from the start, but fine. This is the memory part. So when we can have high memory, we just say whenever there is a memory leak. Okay, is there a memory leak? So architects, tech leads, high level, they would not ask, oh, is the memory high, is the memory down? They will just use the wordings, is there a memory leak? And then the whole picture would go in one direction, what to check. Fine, so this is important. So how do we know we have memory issues? Just plain simple, memory is high. Okay, this is the first point. What else? We see crashes. Okay, crashes happening due to out of memory. So it's evident, oh, memory got full, memory is low, there is memory leak, whatever. So what will the tool do here? They will give us like a visualization, which objects are kept in memory for a long time. Okay, so we have something like graphs, we call it like flame graphs. So employee object, and then is employee sub object, and this is bigger. If you just search in Google flame graphs, you will have a good representation. Something something something, it's like, not going into detail because it would be lengthier. But here the thing is, we need to understand which objects are there which are just in memory, not getting cleared, and which are getting the highest bulk or taking the highest bulk of memory. In the tools you will easily get in terms of the sizes, number of references. It's very interesting. I would say just have a look in the flame graph memory profiling. Just go in Google, just go into images. Yep, you'll get the idea. Fine. So similar set of tools, let me think of .NET would be Visual Studio. We have dot memory also, which is very popular. Okay, Java same, JProfiler. These are like my favorite, so I'm just naming them, but there are other tools as well. Okay, fine. Now the third part would be thread profiling. So whenever you run your application, you're just spinning up a process, right? It's a process, and who powers the process? Threads, right? So this is a process 1, and how it is running? Threads are taking different codes, running different codes, going to different functionality. I will have a very good explanation of how everything is powered by threads in the software world. If you understand threads, half of the concept is gone. You would understand everything. Okay. So performance issues, you have to think of thread. Mhm. You have to you have to see behaviors of multi-threading. These are like, if not done properly, can lead to serious performance issues. Multi-threading, or you can say synchronizations of the threads, because here they will fight and we will come into a bottleneck between the threads. Bottleneck. Everybody wants to get out and do work, but no, there's no space. Yep. So I told blocking, it's a similar thing like waiting. Okay, but let me go to the how we would understand. Okay, so from the tools we would know if some thread is not going fine. Is I told a lot about blocking, right? Blocked threads, find them. Okay, block threads, waiting threads, if some thread is waiting to do its thing, right? Suppose it is going to load a dashboard, okay, after some computation, and it is the UI thread or whatever is populating it, it's ready to do its work, but it cannot, it's waiting for something else in its flow. Waiting threads, try to find them. Okay. Yep. So you will have thread profilers. You don't need to worry too much into the concepts, or what should I do, because all the tools will help you, right? They will have a very good UI. You will say CPU profiling, this functions, memory profiling, this objects are causing the issue, threading, these threads don't look good. So this is like a high level session on this. What different profilers or profiling do we use? Okay, now we have to think of, yeah, this is the fourth part, input output profiling. Okay, input output, like whenever we are reading, writing a disk, read write operations, okay, on a disk, or you are doing some network operations, fine. Sometimes these can take a lot of time. These are like heavy operations whenever you are fetching from database, reading from disk, right, or making some network calls outside of your process. Okay, so the tools will give you if there is high input output wait time. Okay, or it can also show you the time spent. It cannot fine tune it, but it can also give you time spent. Okay, and you have to be also in your mind think of which particular threads of flow is reading or writing or making network calls, and you need to relate it with the tool. Okay, yes, fine. Similar thing, because I was calling network operations, right, but we have something separate for network, because it's a big concept. We even have different specialized networking team in enterprises, big organizations. They could also assist you, but you should also know. Okay, how do we do network profiling? So whenever we are sending data, receiving data, if we have latency at the network level, slow data transfer is happening, Okay, then we can utilize some tools, and they will give you in very low level. Okay, the packet level, TCP level. These are Wireshark. This is very good. This will work with like independent of the tech because it's at the network level. .NET, Java, whatever. Fiddler, many people would have heard of. These are like the most popular ones. Okay, in terms of Linux, people say TCP dump, netstat, but the concept remains the same. Okay, just go into Google, type images, and it will represent the image through which you can relate. Oh, these kind of details I can also see from my HTTP traffic or whatever network protocol we are doing. Okay, yes, I was saying something about the CPU and garbage collection relation, right? So yeah, I think I have some time. I try to finish it in 30 minutes, but okay, let me put it as a separate topic. CPU profiling. Yeah, CPU profiling. So when we are having frequent garbage collection, right? Okay, memory is increasing and we have frequent garbage collection. That means other things are not getting so much importance from the CPU. Okay, and we may have latency in our UI or in our response because the garbage collection is doing the work, and the threads which are like responding to your UI, your API, those would be in a pause for some time. It's not very much, but if the garbage collection is very high, you would have a noticeable difference. High GC latency would also increase, or you can say response of application would decrease. Yes, so here also you would utilize the same tool, and you will get the details of how your garbage collection is performing. Is it slow? Is it fast? Okay, what is the time taken by garbage collection? GC time, GC frequency. All these are related to CPU only, but these we can see separately with the tools. That is the point. Fine. And now the biggest. This is like infra or system level or infra level profiling. You will get everything. Okay, so there are many APM tools, application performance monitoring and observability tools. They will give you everything. You don't need to like have a look. They can keep you alerted. Okay, real-time situations also, they will just, you'll have a good dashboard to understand. Some can even predict beforehand what will happen and how is it going. So you would have heard tools like Datadog, Dynatrace, Splunk, New Relic, and a lot of things are coming up in the observability domain. Okay, so it will provide a full picture of the health. You'll have everything. You don't need to do separately for CPU, memory, garbage collection. Everything would be in one dashboard. Even at the OS level, it will provide some details. Okay, fine, guys. I would try to make a video with the diagrams when I would do like in a real session. I would have some examples and try to go through it and just explain in like not a hands-on level, but I would say hands video level. Okay, I'll show you in the UI how it is looking. So fine guys, I hope you benefited from this. So apart from this, these, if you know this, you don't need to know anything else for performance profiling and improvement. These are the basics through which you would figure out. So just a quick recap: see how CPU is going. Second is the memory profiling, how the memory is going. And then threads. These are very, I would say, like a culprit in many situations. Block threads, waiting threads. Input output profiling. Okay, how the disk is being read, there is latency, is the disk slow, what is happening. You'll get all the data. Network, Wireshark, Fiddler. These are like very, very beautiful tools, I would say. CPU profiling in terms of garbage collection. And if you have the budget, if you have in your company such tools, just try to visualize them and it would be really beneficial. Okay, in interviews also this can be projected, because one of the most common interview questions now is how would you speed up your website application, how would you find the performance issues, what methods you can take. Okay, so you can bring all these points. Fine guys, let's meet in another episode. Okay, if you are liking my videos, if you're finding it something different from other topics, other channels, the information you already have, okay, please do subscribe and try to get notified with the bell. Okay, if you have any doubts, questions, just post it in the comment. Okay, and I will definitely respond. Keep learning guys. See you in the next episode. Thank you.